Present topic is de Broglie's hypothesis of matter waves. Before going to that, just we should understand what is meant by a wave and what is meant by a particle. That is wave and particle duality of radiation. Particle and wave natures are completely different. About the particle, what is meant by a particle? A particle has mass, it is located at some definite point, it is specified by its mass and its velocity and its momentum and its energy. These are all the physical quantities associated with the particle. A wave means it is spread over disturbance in space. It can not be said to be located here or there. It is specified by its frequency by its length and by its so if you see these two aspects, it is difficult to accept that radiation has a wave which is spread over some space and also a particle which is located at a point in space. But this acceptance is essential because radiation sometimes behaves as wave and at some other times it behaves as particle. Because radiation including visible light, infrared light, UV, X-rays, etc. behaves as waves in experiments based on interference, diffraction, etc. which which requires the presence of two waves at the same time and position, and it is difficult for two particles to occupy same position at the same time. We conclude that radiation behaves like wave. When radiation interacts with matter in the form of photons or quanta, in explaining photoelectric effect or Compton effect, etc., therefore we conclude that radiation behave like particles. Radiations thus sometimes behave as waves and at some other times it behaves as particle. It means radiation has a wave-particle dualism. Radiation cannot exhibit both the wave nature and particle nature simultaneously in the same experiment. So this leads to de Broglie's hypothesis of matter waves. Louis de Broglie has extended the wave-particle dualism of optics to all the fundamental entities such as electron, proton, neutron, atoms and molecules, etc. Like radiation, matter also has dual characteristics. According to de Broglie's hypothesis, a moving particle is associated with a wave which is known as de Broglie wave. The wavelength of this matter wave is given by him as lambda is equal to h by mv, where m is the mass of the particle and V is velocity with which it is moving, P is the momentum which is equal to mv. In the case of radiation, we can get this equation by comparing with the radiation. In the case of radiation, the energy of photon, according to quantum theory, that means Planck's theory, that is given by, in the case of radiation, which travels in the form of photons, the energy is given by h nu, or equal to hc by lambda, where c is velocity of radiation and lambda is its wavelength in vacuum. And according to Einstein's mass energy relation, you can write the same as the energy can be written as E is equal to mc square, where c is the velocity of radiation. You know that is 2. So using both the equations, we can write that from both the equations, that is mc square is equal to hc by lambda, or lambda is equal to hc by mc square, or lambda is equal to h by mc, where mc is called, you can also call it as momentum, lambda. So in the case of radiation, you will get the wavelength of the wave by the equation h by p. In the same way, de Broglie wrote in the case of material particle. Similarly, for material particle, of mass m and velocity v, he wrote the wavelength associated with the particle. The wavelength of the wave associated with the particle is written by de Broglie, that is h by mv in this case, or h by p. If E is the kinetic energy of the material particle, then we can write that equation as that. First we write the equation for energy, that is half mv square multiplying and dividing with m. We can write the same equation as m square v square by m, that can be written as p square by 2m, or p is equal to under root 2me. So de Broglie's wavelength associated with the particle in terms of energy can be written as that lambda is equal to h by p is nothing but h by under root 2me. So we can get this wavelength if you know the value of E. That will be different in different cases. In the case of a charge q accelerated by a potential difference, which is accelerated by a potential difference, that is v, then E is equal to qv in this case. So lambda, the wavelength associated with this particle or charge moving with velocity v, can be written that by substituting E value, that is h by under root 2me is nothing but under root 2m qv, where v is the potential difference. In the case of an electron of charge E accelerated under a potential difference of v, we can write the lambda, the wavelength of the matter wave associated with moving electron, can be written h by under root 2m ev. In this way, we can calculate the wavelength of the matter wave of a moving particle. This is called as hypothesis of